Hello guys, and welcome to another video. And so today we will talk about algebraic expressions, especially in variables, constants, coefficients, terms like and unlike terms. So let's move on. And what is a term? So a term, when you think of a term, uh, it's simply a single number. It can be any number, a negative number, positive number, or a variable or the product or quotient of numbers and variables. So by this sentence, it can be a variable, it can be a product or the quotient of numbers. It can be any, it can have exponents. And one example of a term can be 5t to the power 5. And there's also multiple types of what do you call there's multiple types of polynomials based on the number of terms it has. So one type is the monomial. A monomial only has one term. It can be derived, or it can be denoted as, sorry, not derived, denoted. It can be one term, 5t, 7b, zb, that can be still a term, but it should be lowercase letters. And another one would be 7. Why am I writing z? 7 qp. It can be a monomial. And moving on, there's binomial and trinomial. So in a binomial, by the word bi, the bi means two. Like if you know bicycles, they have two wheels. Same here in polynomials. I mean, same here in binomials. There's two terms in binomials. Two terms. So it can be 5b squared minus 3t. Or it can be 4 over 3xt plus 5t. This is one term, and this is another term. Another example would be 9b squared plus 7q. And that's the important thing you need to understand about binomials. So, but next is the trinomials. Trinomials. By the word tri means it has three terms. So one common example is standard form of a quadratic formula. Yes, standard form of a quadratic equation, sorry, not formula. And I can show another example, like 40b plus 7b minus 6 q squared. But the proper format of this would be 6q squared plus 4tb plus 7b. That's the important thing. Always remember, trinomial has three terms, binomial has two terms, and monomial has only one term. And let's talk about polynomial. The last thing, polynomials. By the word poly, it means a lot. Polynomials means many terms. So it can be 7b squared plus tb minus 9 plus 6. This can be a polynomial because it has four terms. Because it has four terms. And another example would be multiplication of algebraic expressions can be denoted like this: 8q minus 5u plus 7, I would say c minus 7d. This can be a polynomial. Why? Because there's 1, 2, 3, 4, 5. Polynomials means there's many terms. So let's move on. Wow. A constant in mathematics. So a constant in mathematics is a value that never changes. If you think of fixed numbers like regular numbers, let's say 5, negative 3, 2.5, because basically a numeric constant doesn't change. Common examples of numeric constants like the pi. If you know the value of pi, 3.14, it's always 3.14. It doesn't change no matter what. And another example is the Euler's. Another example would be the Euler's number, or the Euler's number. It can be its main value or its constant value, 2.71828. And another example is an imaginary number or unit. Sorry, imaginary unit, I. So, and also in mathematical formulas, there's constants. And also, I forgot to also mention the golden ratio. If you know the golden ratio is a geometric proportion that's often used in art and even in architecture. It's denoted like this, or phi is equal to 1.61803. Another example of a constant, but we're not going too much deep in that. I'm just teaching the basics of a constant. Constants can be a single term, a single number. It can be fractions. It can be decimals, and in algebraic expressions, it can be denoted something like this, where b is the constant, or another example like 5t minus 7 equals 72. I can say sorry for the interruption. So I can say in this problem, there's two constants, negative 7 and 72, because those numbers, those do not change. And the coefficient here is 5, and the variable here is t. So that's all you need to know in constants. So coefficients, if you remember coefficients is something, is a number that multiplies a variable in an algebraic expression. So examples of coefficients can be 5b, 7t, and 7z, 8p, or so on and so forth. It has a variable, and it has a number, and it has a variable. It may have an exponent, but its main parts, or its main elements, is a number and a variable. And next is the common types numerical coefficient. So yeah, the pure number part multiplying a variable. So a pure number part multiplying a variable. So sorry for the interruption again. So common examples like 5t squared, I can say 6b, 7c. So basically, I can denote it as something like it should always have a number and a variable. Okay. But that's all you need to know for numerical coefficients and leading coefficients. So if you know polynomials have exponents, and the meaning of a degree or the definition of a degree is basically a term that has the highest exponent value. So, like for example, like 5b cubed plus 7t squared plus 3x. So I can say that the leading coefficient here is here. This is the leading coefficient, the leading term. It should always have the highest degree. That's all you need to know for the leading coefficient. And for like terms are algebraic parts that share the exact same variable and exponents, while unlike terms have different variables or different powers. So by that division, so for example, I'm given 7x squared plus b, 8x squared. If I add both of these, I'll have 15x squared because I can add it because I have the same exponent, the same variable as the other one. And another example would be 16xy plus 72xy. So if I add the both of this, the two of this, basically, I can say this is 82xy. No, sorry, 88xy. But unlike terms, on the other hand, so I can basically show it something like, by the word unlike, it's different from each other. So that could be 7t plus 7b. I cannot add the both of this because they have different terms. They're different from each other. And next would be 8b squared plus 7b. The thing about this binomial, this polynomial, it doesn't have the same number of exponent, but I can say that it has the same variable, but the number of exponent, that is the thing that makes it different from each other. So it's unlike. And that's all you need to know for this video, and I wish you learned something, and maybe in the next video I'll provide practice questions. Bye bye.